Okay folks, in this lesson we take a quick look at the geometry and advanced section of the Arnold standard surface shader. I'm just going to be taking a look at the more important parameters and let the rest to you guys. So the first parameter that we have here is this thin wall parameter, which allows you to simulate translucent surfaces that allow light rays to go through, and it can be used for shaders such as paper or leaf, and it is recommended that this only be used with thin objects. Let me show you how this works. I'm gonna just hide this shader ball and also go to the Arnold sky and turn off. Now I don't have any light. I have this cube geometry, so let me just unhide it and create an Arnold point light. Let's make sure it's inside the cube, and I'm just going to increase the radius to something like 0.1, so we have a spherical, basically a light. Now if I run the active shade, even though we have this light, but we don't get anything because the cube won't allow any light ray to pass through it. So if I create a new Arnold standard surface shader and assign it to this cube for now, come down to the geometry section, enable thin walls. Now we also need to have some sort of subsurface scattering. Let me just, okay. So now if I disable thin wall, you can see the light rays can't pass through the cube, but when I enable the thin wall, now it becomes a translucent object that allows the light rays to pass through it. So that's the thin wall that can be used to create shaders such as leaf or paper. Let me just delete this Arnold light and hide the cube, and let's unhide our shader ball again and turn on our Arnold sky as well. Let's get back to, let me just delete this shader and get back to the shader that is assigned to the shader ball here. If I come back to the geometry section, let me actually open up the network editor. Next we have this cutout opacity, which is exactly like alpha channel in Cinema 4D. Unlike transmission, whereby the material still considers diffuse, specular, etc., opacity will affect the entire shader. So let me first of all make sure we have opaque disabled for this shader ball, show custom parameters, and uncheck opaque. And now if you can see when the opacity is set to white, we get a fully opaque shader, and if I use a darker color, now we start to get a semi-transparent object. Let me just increase this so you can actually see it a bit better. Now we get this kind of semi-transparent object, and as we use darker color, we're gonna see obviously more transparency, right? And we can obviously use texture to control the opacity. Let's say if I use a simple checkerboard as the geometry cutout opacity, let me just select the checkerboard and increase the frequency to something like 5 and 5, or even 10 and 10. Now as you can see, we have our opacity being controlled by this checkerboard pattern. Let me disable that. Next we have this normal parameter, and this is where you connect your normal or bump map. So let's use an image node. We're going to be taking a look at the normal and bump mapping in probably the next lesson, but for now let me just quickly show you how to, for example, do a bump mapping. So you need the image. Let's say we want to use this parquet pattern, and then we need a bump 2D node. We connect our bump map that we want to be used as the input, as the bump map input for the bump 2D node, and then connect this to the geometry normal. And now let's see what we're gonna get. So now as you can see, we get this nice bump mapping. For now, let me just delete this connection. In the advanced section, the first parameter that we have is the caustic. And generally speaking, because of the Arnold's nature, it is hard to get crisp, sharp caustics, but it is possible. So let me just come down here. I have this abstract object. Let me hide the, just turn off the Arnold sky and create a new standard surface shader. Let's use the glass preset and connect it to this abstract object, and also make sure we obviously have the opaque. And if I run the make sure we have our Arnold sky actually enabled, and hide the shader ball, sorry. So this is what we have, and if I select my standard surface shader, I can go ahead and disable and enable caustics. So we can enable the caustics. And let me just show you tool render with and without caustics in my picture viewer. So this is the first render in which the caustics was disabled, and in the second one the caustics was enabled, right? If I just zoom in, so this is without caustic and this is with caustic. You can see we get these more focused lights. Okay. You can see obviously you get this extra noise, and to control the noise from the caustics, the parameter that you actually need to work with is the specular blur. Okay, so if you increase it, you can get rid of the noise that's caused by the caustics if you wanted to. Also, I have another example here with a reflective surface. This is without caustics and this is with caustics. If you just take a quick look, you can see it gets a bit brighter, and if you take a look at these areas, you can clearly see the caustics effect, but it's very noisy. Okay, so that's about caustics. And let me just hide this object and unhide the shader ball again. Let's run the active shade. We have these two important parameters, indirect diffuse and indirect specular, and basically using these two parameters you can control how much the GI or global illumination will affect your shader. The indirect diffuse, you can see, is the amount of indirect diffuse lighting received by the shader. Values other than 1 will cause the material to not preserve energy, and global illumination may not converge. So if I use a value like 0, okay, let me just turn off the specular, wait for the shader. Okay, make sure we are in the right shader. This is the shader that is assigned to the shader ball. So if I zero out the indirect diffuse, you can see no indirect diffuse affects the shader. Obviously, we can increase the indirect diffuse to be more than 1, and this way the shader will get more indirect diffuse lighting, but this is not physically accurate, and you better stay at 1 to get physically accurate results. And we have the indirect specular, which is the amount of specularity received from indirect sources only. So if I just use a metal preset quickly here, okay, we can zero out the indirect specular. So as you can see, we don't get any indirect specular from the scene, and obviously we can increase this value to be more than 1 to get more, but in this case 1 is the physically accurate number. Okay folks, so that's about the standard surface shader. We discussed it in 8 lessons, and hopefully you learned something, and I will see you in the next lesson to talk about another aspect of shading in Arnold for Cinema 4D. So see you there.